Section 1.2 is on measuring and constructing segments. We're going to learn how to use the ruler postulate, copy segments and compare segments for congruency, and use the segment addition postulate. Our essential question is, how can you measure and construct a line segment? So we're going to start this off with just a little bit of a definition here, kind of a lot like what we did last lesson. In geometry, a rule that is accepted without proof is called a postulate or axiom. A rule that can be proved is called a theorem, as we are going to see later. So what we're going to do here is we're going to talk about this guy. This is a famous guy. His name's Euclid. Just a quick crash course on some history. Euclid wrote a book, really, it wasn't really a book. It was just a writing, a publication that was called The Elements. And it's been referred to as one of the most successful and influential pieces ever written. It was written back in about 300 BC, and what Euclid did was he based all of the geometry that he tried to explain to people off of 5 original rules, postulates, axioms, whatever you want to call them, and everything else was built off of those 5 original principles. And then through the process of using logic, he was able to kind of prove everything else we know about geometry, basically to what we know about geometry today. One of the coolest classes I actually had in college was we took Euclidean geometry axioms or postulates, which are listed right here, and we flipped them upside down and basically threw them out the window and started from scratch, but started upside down. And it was one of the most challenging classes I had to do because a line was no longer a line, it was an arc. And a flat surface, a plane that we're kind of seeing a little bit about now, a plane isn't a plane in non-Euclidean geometry, it is the surface of a sphere. But anyways, it's kind of besides the point. This guy, Euclid, came up with these 5 original axioms, rules, postulates that basically every bit of geometry is based off of. Those 5 original ones, in some degree, were a straight line segment can be drawn joining any 2 points. Any straight line segment can be extended indefinitely in a straight line. Given any straight line segment, a circle can be drawn having the segment as a radius and one endpoint as center. All right angles are congruent. And the 5th one's kind of up for debate depending on who you talk to, if this is a theorem or if this is a postulate. But I'll read it anyways. If 2 lines are drawn which intersect a third in such a way that the sum of the inner angles on one side is less than 2 right angles, then the 2 lines inevitably must intersect each other on that side if extended far enough. This postulate is equivalent to what is known as the parallel postulate. Again, sometimes some people think that that is more a theorem than a postulate, but those, for the most part, are building blocks of all geometry. We are going to be looking at a very, very watered down version of that. We're not going to go into as much detail as I did in college, where we had to prove literally everything we did. But we are going to look at geometry in the sense that we are going to be basing things off of postulates and axioms. So here's our first postulate we're going to look at. Our ruler postulate. The points on a line can be matched 1 to 1 with real numbers. The real number that corresponds to a point is the coordinate of the point, which is probably making and ringing bells here from Algebra 1. The distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. The reason why we have absolute value here is because it makes sense. If I'm talking about the distance, I know that the distance between 2 objects or 2 things cannot be negative. Distance cannot be negative. If I'm driving down the road and there's a car a mile ahead of me, the distance between us is a mile. If I'm driving faster than a car, eventually I pass it, and eventually I get a mile past it, the distance between that car and myself is still a mile. So really this distance is not positive or negative. It's just value between the distance between 2 different things. Okay. So if we want to figure out the distance between 2 points, we actually have to look at the absolute value of the difference of the coordinates. Okay. So what we're going to do is we're just going to take a little bit of time here measuring. It's going to be kind of hard to do because when I print this out, it's going to probably act a little bit different than what we have here on the screen, but I can kind of show you the process. It says measure the length of segment ST to the nearest tenth of a centimeter and measure it again to the nearest 16th of an inch. So I'm going to take my ruler. Hopefully we understand which one's centimeters, which one's inches. Centimeters is the one that would probably go up to about, at a normal ruler, well, about 2.5 centimeters per inch, excuse me, on a normal ruler that has 12 inches in it. That puts us at roughly 30 centimeters. Okay, so if I want to measure this thing to the nearest tenth of a centimeter, I'm going to take the metric portion. I'm going to slide this guy over. I'm going to plop the 0 right there in the end. I'm going to have to pause the video and turn the snaps off. Let's try that again. No, my ruler doesn't snap. I'm going to take that ruler, place it right on the end, and measure all the way down. In this case, it looks like this is exactly 5 centimeters. Now, depending on if you had science and significant figures, I'm not going to worry about significant figures a bunch in here. If it says round to the nearest tenth of a centimeter and I go 5 centimeters, I'm not going to freak out. It's not 5.0. It's all right for me. Okay. Next, we also have to do the same thing, but now we have to do it to the nearest 16th of an inch. If that's the case, I take my ruler, I flip it upside down so that now I'm looking at the measurement in inches. And the way this lines up is it looks like if I'm running to the nearest 16th of an inch, first of all, if we take a look at a ruler, if from here to here is an inch, and I break that in half, that means that bigger mark is 1/2 inch. The next big mark is 1/4 inch. The next mark is 1/8 inch. And the one below that, the smallest mark on that ruler, is 1/16 of an inch. So if I am asked to measure to the nearest 16th of an inch, I'm measuring to the closest little mark on that ruler. We'll see the same thing with tape measures when we use them later in the semester. Okay, so if I were to, again, take my ruler, throw it up here, I kind of luck out because it looks like this thing, I can't quite tell if it's 2, so what we'll do is we actually won't call this 2. I'm going to call this 1 15/16. 1 15/16 of an inch. And again, as Mr. Hughes has kind of talked about, we kind of talked about the symbol for inches is those 2 little marks up in the top. Okay, what we're going to do is if you were actually have done this on your piece of paper, instead of getting the measurement of 5 centimeters and 1 inch and 15/16 of an, excuse me, 1 15/16 of an inch, if you actually had this on a piece of paper, the measurements I got were 3.8 centimeters and 1.5 inch. Again, I said that we're going to round to the nearest 16th of an inch. This was really, when I measured this, it was 1 8/16, but there's no reason for me to write that as 1 8/16 because it's 1.5. Again, I can either use the inch, I can actually write out IN for inch, or the more efficient way of doing this would be to put the inch mark up on top. Inch mark up on top. Okay, so what I want you to do right now is hopefully you have something around that you can use for measure. Hopefully you have a ruler, you're in a classroom where you can find a ruler, or you're at home and you have a ruler or a tape measure. What I want you to do is take a little bit of time just practicing measuring. We're going to use a ruler to measure the length of the segment to the nearest 16th of an inch, and then again to the nearest millimeter. This time not to the centimeter, to the nearest millimeter. I want you to pause the video quick, try that. I'm going to throw my answers up here in a second, and we'll go from there. All right, the actual measurements on the hard copy, I got that segment MN had a length of 2 3/16 of an inch. Segment PQ had the measurement of 1 7/8 inch. Segment UV had the measurement of 1 3/16 of an inch. And segment WX had a measurement of 1 11/16 of an inch. MN 55 millimeters, PQ 47 millimeters, UV 30 millimeters, and WX 43 millimeters. Okay, that's what I got. And there is our introduction into line segments, constructions, measurements, and a little bit of history on Euclid.